In this video we will see how to do a Fibonacci series generation using assembly language programming of 8086 or x86 based programming. So what you need to know is what is exactly a Fibonacci series. So Fibonacci series is a series in which the addition of two preceding numbers is the third number. Okay, so that is basically a Fibonacci series. So here the series starts with 0 and 1. So the third number is 0 plus 1 1. Okay, so again these two numbers, okay, 1 plus 1 2, 2 plus 1 3, 3 plus 2 5, 5 plus 3 8, 8 plus 5, and so on. Okay, so this is how this series work. So this is actually a very basic program that is done using C or C++ for any of the CS101 courses. Okay, so this is a very simple example that is done there. So we'll try to replicate the same example using assembly here. Okay, so for that thing what you need to do is first you need to write whatever you write usually. Okay, cs comma code ds colon data segment. Okay, so here usually the number of series, if you are asking, usually the input is n, that is the numbers that you want to generate in the series. You want to generate the series up to which number? Okay, so if I say 5, then 1 2 3 4 5 3 4 5. Okay, so the fifth number will be this one, 3. Okay, so we will take input from user up to which number he wants to generate the series, and based on that we will process accordingly. Okay, so let's get started. So data ends, and here we will take the number, okay, number from user, so numf, okay, db, and let's say 05h, and here will be the actual series. Still we don't know, so we'll use a question mark here, and let's start with the code. So here you need to remember how we did the looping and parts in the previous programs, so that will be useful this time as well. Okay, so very simple program. Start mov ax comma data mov ds comma ax. So if you are not sure what exactly this thing does, so basically it loads the data segment. Okay, this line loads data segment, and it is advisory, or you can say it is kind of a directive to use only AX to load this registers. Okay, any type of segment registers. Other registers usually don't work unless you are using a custom made assembler or anything, so on that it will work. In most assemblers you will have to use AX only to load the data segment. Okay, so next thing that we need to do is here is first we need to load the counter here. So counter is this number numf. Okay, so here what you could do is move cl comma of numf. Okay, so this will load the counter, and as I said, the series begins with 0 and 1, so we will load two operands with 0 and 1. So we will load al with 00h. Okay, we will load pl with 01h, first operand, second operand of Fibonacci. Okay, so after this is done, what we need to do is we have taken a series array, or you can say series memory location, so we have to load that with these values. So here what I will do is lea load effective address si comma series. Okay, so it will load this. Okay, loads effective address of the memory location, initial location, that is initial start location. So load effective address is the initial start location, which will be stored inside the SI register. So here what we need to do is we have to load this first value, that is 0, inside as well. So mov si comma al, first operand loaded in memory. Okay, so the first operand is loaded in memory. Then you need to increment this location, so this will increment this location, increment si, load second as well. Increment si to point the next consecutive location. Okay, if you have missed out the previous videos, then this can guide you. Okay, so here after that, second operand loaded in memory. Okay, so what we need to do here is, once we have loaded all these things, here we have to take the addition of these things. Okay, so we have loaded two of these things. So what we need to do is, we have already loaded two values here. So what you can do is, you can deduce those two values from CL. Okay, you could simply write DECCL 2 times, because you have already taken two values here. Okay, so that you could do, or you can simply consider those values of the series as well. So here next thing we need to do is add AL comma BL. See here, first two operands, or you can say preceding operands. So 0 plus 1 is 1, so these two are operands, so AL comma BL is added. And now we need to push this again, we need to increment SI here, and this you will push inside SI, sorry, AL. And what you will do is move AL comma BL. Okay, so here assume these two numbers, okay, 0 and 1. So you have pushed 0 into the memory. Okay, so like AL initial value was 0, okay, and BL initial value was 1. Now what you did is, you pushed AL to memory and AL to move AL comma BL. So what here happened is, you moved this value, so AL is now 1. See here, you moved this value of into this thing. And now what we'll do is BL, sorry, so here what value you had pushed to memory? 0. Okay, so here again that number will be pushed. Okay, so here AL was 0, but you pushed it inside, so BL, so BL is now 0. And then the next number, so here again, see here the value of AL is the Fibonacci sequence. Okay, so here AL was 0, so first number 0, then second number is 1, then push AL to memory, then what happened, AL is now again 1. See here, 0 1 1. and this time you copied BL value again, so here BL is equals to 1 as well. Okay, so now 1 plus 1 2, so this way you will have these values. Okay, so let's write the code. Okay, hope you'll get it. So here you will decrement the count, okay, and place a J and Z back, okay, label here, and you need to place that label here back. Okay, and what will happen here is, see here, the result will always be in the AL and will be stored inside the memory. So after this is done, your task is done, and finally you can write int 03h and save the program. Tasm bin fibo dot asm. Okay, fire up this thing, DOS box, mount home, okay, drive C. Tasm cd bin, sorry, tasm fibo dot asm. Okay, so we don't have any errors. Okay, but I forgot to comment this thing. Okay, so we have already generated two numbers. Okay, so this is why we have decremented the location two times. Already generated two numbers, series, so decremented. Add the operands. Point the next location. Okay, here what we are doing is we are moving to the next location, incrementing the SI pointer. Here we will fetch the second operand from set the next number in the series. Move BL value to AL. So this will move this thing BL to AL, and here fetch memory saved operand into the BL register. Decrement counter. Jump until counter is not 0. Okay, so this is it. Okay, so let's save it again, and okay, so this is done. T-link and T-link fibo and TD fibo. Okay, so here what I will do is I will directly start the program and will show you the dump here. Okay, sorry, F10, run. Okay, so it reached the breakpoint. Okay, so here I will show you the dump of variables. Okay, so see here, so we had to generate the series till 5, So see here, 5, first it's 0, 1, second, third, again 1, 2, 3. Okay, so it's still 5 only. So what we need to do is we'll just extend it a bit. Okay, just a minute. Okay, so here if we change the value to 10, okay, see here, as I wanted to mention here 10h, so 10h is not 10 decimal. Okay, so let me show you this thing. So 10 in decimal is a in hexadecimal. Okay, so here if you are writing hexadecimal 10, so it amounts to 16. Okay, so this you should remember. Okay, so if you don't want to mess up any outputs, then you need to know a bit about hexadecimal numbers. If you cannot remember or these numbers, then you can use these sites for conversion. Okay, so here I will keep it 10h only, so I can generate a longer string. Okay, so you have to assemble it again now. T-link here, hope you have seen this thing. I incremented this number just like that only, nothing else, and fibo dot, no, nothing, fibo, and td fibo dot exe. Okay, so F10, run, it reaches the breakpoint, and let's see the dump now. Dump, see here, this is the number 10 that we had loaded. Then the series begins in the next location. First number is 0, second number is 1, 1, 2, 3, 5, 8, and just a second, if I, let's see if I can move there. 5 and 8, 13, so 0d, I guess. What is 0d? 0d, see here, 13, see here, move accordingly. 0d, 15. So here you should know this conversions to understand this thing. Okay, 21. Okay, so series is perfect, it is showing in hexadecimal, so you might get confused if your program is proper or not. So for the initial numbers it will show you properly, for others you need to have this lookup table to understand what the values it is giving. Okay, so this was a very simple program of Fibonacci. Hope you guys have understood this program. Okay, I've tried my best to explain it. Okay, thank you.